So we finished our unit on basic trig. Now it's time to look at a few more things that you can do with trig, some things that get a little more advanced. So this is a very short unit that just consists of 3 short lessons on some advanced trig topics. Now again, next year as you get into Algebra 2 trig, you'll go even more advanced. But these are some things that sort of fit into the geometry world with trig as well. So we're going to look at our first rule of trig today, which is the law of sines. So let's take a look at our notes. Remember, you can print these notes out if you want to, or you can just take notes on regular paper, but you definitely want to take notes. So first thing, can I use basic trig on a problem that looks like this? Can I use sine, cosine, or tangent? If so, or if not, explain why or why not. Go. So hopefully you were able to look at this and go, no, you can't use basic trig on this. No, because A-U-S-E, it is not a right triangle. Remember that all of our basic trig can only be used on right triangles. This triangle, we have no way of knowing that it's a right triangle. I have a 42-degree angle here, but I don't know anything about the other 2 angles. I don't know their right angles, so I can't assume that they are. So we need some other rules. Luckily, mathematicians have helped us out here. Okay, we can work with this by using what's known as the law of sines. Now, the law of sines is basically a set of proportions. It says that the sine of angle A over side A is equal to the sine of angle B over side B, which is also equal to the sine of angle C over side C. So basically what you're looking at is if I take any angle and set the sine of that angle over the opposite side. So angle B, opposite side is B. Angle C, opposite side is C. If I set the sine of the angle over the side opposite, those 3 ratios are all proportional. There is a proof of this. I'll have a separate video if you really want to see the proof. It's not important, but for those who are really interested in it, I'll show you a proof of this and you can see the link that's here. Okay, but how can I use this? That's probably more interesting to many of you. So let's look at a problem. I need to solve for side A and side B. And again, notice, not a right triangle. So the minute I realize it's not a right triangle, I can't use any of my basic trig functions. I also can't use Pythagorean theorem because it's not a right triangle. So I'm going to go with my law of sines. So using my law of sines, I'm going to set up each part of it. Okay, so the sine of angle A, which is 75 degrees, over side A. Notice again, this is why it's important that we use capital letters for angles and lowercase letters for sides. For B, the sine of angle B, which is 26 degrees, over side B. And I'm going to go ahead and set up my last one too. The sine of, whoops, I need to get angle C. Well, luckily, we have 2 angles. And I remember that the angles of a triangle sum to 180 degrees. So I can find out that this last angle is 74 degrees. Okay, so the sine of 74, not 75, sine of 74 degrees over side C, which is 12. Now, if I tried to cross multiply these first 2 here and there, I'm going to have 2 variables, and we can't do that. Plus, doing a proportion with 3 ratios is not very useful. Let's break this up as 2 different parts. This one has an unknown. Everything here is known. So I'm going to set this one equal to that one. So when I do that, I can say the sine of 75 over A equals the sine of 74 over 12. And just like any proportion, I can now cross multiply. So A sine of 74 equals 12 sine of 75. Now remember that sine of 74 is one big number. sine of 75 is one big number. So what I'm going to do is I'm going to divide by this sine of 74 on both sides. In fact, if I wanted to write that out, I'm going to divide by the sine of 74 and the sine of 74. That's going to cancel out this and that. Now notice, be careful here because you're not canceling out sine and you're not canceling out 74. This is all one thing. So I can't go sine and sine cancel. That doesn't make sense. It's like canceling plus and plus. It doesn't make any real mathematical sense. So when I do that, I'm going to now end up with A equals 12 sine of 75 over sine of 74. And I'm going to enter that into my calculator. Let me go ahead and get my calculator real quick. Get my Desmos calculator up here. Again, you can download this calculator to your phone. Always make sure you're in degrees. So before I do anything, I'm going to switch to my degree mode. Okay. So our problem there was 12. Whoops. Let's go get was 12 sine of 75. Now, I may go ahead and enter that now. And then I want to take this. Can I even do that? I don't know if I can do that. Divided by, okay, I can divide the whole thing. That's good to know. And we had the sine of 79 in the denominator. If you've got a calculator that's doing this in parts, like your basic calculator, like one of these, you might want to do your numerator, get a decimal, and divide that by the sine of 79. That way you're less likely to get a mistake. Okay, but in this case, I get 11.8081. And there's our solution. So A equals 11.8081. Now, what about B? We've still got to get side B. So I'm going to break this apart here and do side B. With B, I'm going to do the same thing. Now, I now have A, so I could substitute that into here. But remember, we rounded this. And one rounding is going to lead to an error later on. So instead of using something I found, plus, what if I did something wrong, right? I'm going to set these two equal to each other, okay? So when I do that, I'm going to get the sine of 26 over B equals the sine of 74 over 12. Try this real quickly. See if you can get B on your own real quick. All right, so we cross multiplied. B sine of 74 equals 12 sine of 26. Then I divide by sine of 74 on both sides. So 12 sine of 26 over sine of 74. Now you could get decimal equivalents for these from the start, but this way doing it, I only have to go to the calculator one time. Okay, so here I go to my calculator because I like using my calculator as little as possible because it keeps me from making errors. Divided by sine of 79. Whoops, I did something wrong there, didn't I? Let's go back to here. Divided by sine of 79. And there we go, 5.3589. So B equals 5.3589. So that's a basic law of sines problem, okay? It's all based on setting up that proportion. So let's look at what we need to make the law of sines work. You need four things. One of them can be your unknown, but the four things you need is you need two angles and the two sides across from those angles. Okay. Now remember, one of these four is your unknown or what you're looking for. Okay. One of those four things is what you'll call your X or your A or your theta or something. We could use this to find an angle if need be. Okay. So let's try one on your own now. Okay. Let's try this problem. Take a moment and solve for side A. Let's see, we want side A, side B, and angle A. Give me a solution for all three of those. Okay, so I'm going to set up my law of sines. Let's get a better color again. So let's go with, well, angle A is easy, right? Because angle A, we're just going to use our calculator and find a missing angle. So I'm going to say, let's see, 110 and 50 is 160. And I believe that leaves me 20 degrees for angle A. Okay, so that one should have been easy. So to get side A, I want to use the sine of 20 degrees over A. And I'm going to use sine of 110 over 12. Now, the reason I'm using 110 and 12 is because I know that side. So that's a side that I can actually work with. So that's going to be A sine of 110 equals 12 sine of 20. So A equals 12 sine of 20 over sine of 110. Okay. And again, some of you are going to be like, oh, I can just put this in a calculator and get it. But be careful because you can make mistakes real easy. So 12 sine of 20 over sine of 110. 12 sine of 20 over sine of 110. So we're looking at 4.3676. So A is 4.3676. To get B, same idea. I'm going to do the sine of 50 over B, and I'm going to use the same two given things, sine of 110 and 12. So I can cross multiply again. B sine of 110 equals 12. That should be an equal. Sine of 150. So then B equals, sorry about my terrible handwriting here, sine of 150 over sine of 110. And there we go. That goes right into my calculator. In fact, I'm just going to even use this same thing and just change the numbers here. Bam. 6.3851. So B equals 6.3851. Now, I mentioned you could use this to find angles as well. In a problem like this, we already had two angles, so getting the third was pretty easy. But what about a problem like this, where I have only one of the angles? Notice in this problem, that's the only angle I have. I need the other angle. But I do have the side across from that angle and the side across from the angle I have. Remember we said you need four things, two angles and the sides across from them. So I can still set up my equation. Okay, so when I set my equation up, let's see, I'm going to do the sine of angle B over 20 equals the sine of 29 degrees over 11. Okay, simple as that. Now I can cross multiply. 11 sine of B equals 20 sine of 29. Now what I'm going to divide by this time is I'm going to divide by 11. Remember, sine of B is one number, and B is my unknown, so I can't just divide by sine. That doesn't make sense. When I do this, I get the sine of B equals 20 sine of 29 over 11. Now I'm looking for an angle. Remember using that sine inverse? So I tell you what I'm going to do. I'm going to get a decimal equivalent of this fraction, 20 sine of 29 over 11. So 20 sine of 29 all over 11. So we're looking at 0.8815. So let me get here, 0.8815. And now I want to use my inverse. Remember we talked in our last unit about getting angles by using the inverse functions. Okay, so I'm going to go back to my calculator. I'm going to need my functions here. So functions sine inverse of this number. Too bad it won't let me copy that. So I'm going to go ahead and say 0.88147. That should get us close enough. That gets me to 61.8, and we round our angles to a degree. So we'll call it 62 degrees. So B is about 62 degrees. Okay, so there's a case of using the law of sines to find a missing angle. Okay. One word problem, then we'll call it done for the day, okay? How do I know I need to use the law of sines here? Well, let's look at it. First of all, not a right triangle. I can say, oh, alternate interior angles. So this angle of depression is also equal to that angle of elevation. This angle of depression is equal to that angle of elevation. So what I'm looking for, how far is the plane from each tower? So I need to know from tower A and from tower B. Now, okay, we're usually saying, let's label these so that side A is across from angle A and side across from angle B. But it really doesn't matter. As long as you label your things and you know what you're doing, you're in good shape. Names don't really matter that much. So when I go to create my formula now, I'm going to need two different law of sine programs. So across from A is 28. So sine of 28 degrees over A equals sine, find me the missing angle real quick. Go. All right, so you found your missing angle. You should have gone, let's see, 33 plus 28. Take that out of the 180. That leaves me 119 for my missing angle. Okay, so that's sine of 119 over 10 miles. So go ahead. I've got the equation set up. Solve for A now. So you're solving for A. Cross multiply. Divide by that sine of 119. And now we're ready to put that into the calculator. So that's 10 sine of 28 divided by sine of 119. So that length should be 5.3677. So A is 5.3677. Make sure I rounded that properly. Yes, I did. Let's see, did they round it to the nearest tenth of a mile? Always go back and check what you're rounding to. So that means that this is going to be 5.4 miles. Okay, your job now. Now that we set that one up, I'm going to make you do B all by yourself, okay? Set it up, solve for it, find your answer. Go. So setting up B, we're going to do B's across from 33. So that's sine of 33 over B equals sine of 119 over 10. So that's 10 sine of 33 equals B sine of 119. Oops, I kind of crossed my streams there, but it comes out to be the same. So 10 sine of 33 over sine of 119. And I'm going to go to my calculator. And the nice thing is I can sort of love this Desmos calculator. You can kind of just change some numbers. And now you've got it. 6.2272. 6.2272. But they did say round to the nearest tenth. So 6.2 miles. And there you go. So here's a way that we can use trig even when we don't have right triangles. Amazing. Fantastic. Now you've got some work to do, okay? So you've got some homework. You're going to do a quick little quizzes for homework tonight. Doesn't take much. That's going to be what you got to do. Tomorrow we'll talk about, or in our next lesson, we'll talk about our next little law in trig. Okay? Good night.